Okay, started.
There.
Okay. 7-1, we're going to talk about similarity triangle postulates. Okay? So, if a triangle is congruent, what does that mean? If it's congruent to another triangle?
I reach all of it
It's the same, as in what?
equal.
What's equal?
All of
Sides,
it.
angles.
The sides and the angles. All the sides correspond to another side, all the angles correspond to another. If something is similar, two triangles are similar, or two objects are similar, what does that mean?
Their angles are the same, but
Their
sides.
angles are the same, but their sides create what? It starts with a P. What do, no.
Here.
Miss Peters, it's been a while.
Their sides create the same proportions. They create the same proportions. Bryce, stop talking. Connor, stop talking.
First stage.
It's already done. Okay. So they create the same proportions, okay? From there, we then can prove that triangles are congruent using what? What are the theorems that we can use? There are several.
You have
Equal rival.
Side, side, side.
Side, angle, side.
Side,
Angles.
angle, side.
You got
Angle, side, angle.
you got the right triangle theorem.
Well, what's
Not
that?
the right triangle, the hypotenuse leg.
Hypotenuse leg, and then you have angle, angle, side, okay? Now we're gonna talk about how to prove that two triangles are similar. There's two that we're gonna focus on today. One is angle, angle, and one is side, side, side. Okay? The angle similarity postulate says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Okay? Because we know the third angle would be congruent because of what theorem?
Side, side, side.
No.
Angle, angle, angle.
No.
I didn't even
Side,
hear you
angle,
say
side.
that.
Third angles theorem, thank you.
Alright.
I see you.
Okay, so you have angle similarity postulates. Okay, they're for when triangles are similar, not when they are congruent, when they are similar. Okay, so here, you have two triangles. They want to know, are these two triangles similar?
Yes.
Yes.
Why?
90
Because
plus 60 and 30 equal 180. Never mind.
They both
what?
have right angles.
They both have right angles. They have one angle that's the same.
90 plus 60 plus 30 is
Wait,
180.
yeah, well,
Well, that one,
30 plus 60
Right,
is another
sit
90.
down.
It has to
it's
be.
two
It has to
times,
be 60.
it's two times it.
Oh,
What,
okay.
what, Olivia?
So
It's
both,
just the triangle
triangles
twice.
have a right angle.
Yes,
One of the triangles has 30, so
Yeah.
the other one must be 60. One of the triangles has 60, so the other one must be 30.
right, and because this only has one hash mark and that has two, we know that they're not saying that those are congruent to each other. Okay, they have to have one and one. So yes, these are similar using what similarity theorem? A,
A similarity postulate.
A similarity.
But they're not
Okay,
congruent at the same time.
So it can't be. Oh, I see why we don't do AAS. Because we already got one.
right, because it's angle, side for proving they're congruent.
Man,
Okay.
so many theorems, y'all.
Which of these statements is an acceptable way to write that the triangles above are similar? Check all that apply. Okay, first one is PQR. PQR is similar to STU. Does that work?
Yeah.
No.
Yes.
Come on.
PQR is similar to UTS.
No.
No. PQR is similar to STU.
Yes.
RQP is similar to UTS. RQP. Yes. RQP is similar to you. Well, that's because this is supposed to not say something. It's supposed to say something else. Okay. And RQP is similar to STU. No. Okay. So here it says find two similar triangles. How can I figure out what two triangles are similar to each other, or what can I do? I need you to name two triangles that are similar to each other.
Look in here.
Mm-hmm.
Well, DCE and ACB.
Yeah.
Only two triangles.
So triangle DCE is similar to triangle ACB. Okay. And if triangles are similar, remember that their side lengths are proportional. So you can set up proportions to solve things. Okay. Olivia, you have a problem back there?
Sorry.
Oh, Ms.
Sorry.
Peters,
Maybe we should
may use
say.
the restroom.
Go quickly.
Thank you.
Okay, so then you have the side similarity theorem, okay? If the corresponding sides of two triangles are proportional, then the triangles are similar. So if I can take AB over DE, and it's the same proportion as BC over EF, and it's the same proportion as AC over DF, then my triangles become similar using side. Okay?
Yes.
So to prove things are similar, you have AA and you have SSS. What?
No, that's a stupid question.
Okay.
No question's a stupid question, Connor. Come on, speak
No,
on
it's
it.
because I'm not taking notes that I was gonna ask this question. It's a stupid question. Take
Well,
notes.
sounds like a you problem, Connor. I'm sorry. You should say Connor happy birthday. His birthday recently just passed.
No, it didn't.
For-
It's
Yeah, we
2 days ago.
should see.
Or
It's
2
too
days
late to
ago
say sorry.
was your birthday. That is what I've been told. What a wonderful birthday. You're one more year
Old.
on the cake. There'll be cake. Wait, let's zoom in on him.
No.
Never mind.
Okay,
Candle. Oh, all right. Sorry.
so that's side similarity. Now, we need to figure out, is triangle NPM similar to triangle BAC? How can you figure that out?
It's not.
Similar?
It can't be.
Well, what makes something similar?
The sides have to be.
The sides have to be what?
Proportional.
Proportional. So let's set up
Ah.
proportions and reduce.
It still can't.
What?
I did the mental.
We couldn't be.
Well, I don't know.
Oh,
Okay, so triangle NPM BAC. NP corresponds to what side? What would?
so triangle MPN
Mm-hmm,
and triangle BAC,
mm-hmm.
if you, triangle BAC, you can divide it by 1/3, no. By 3, multiply it by 2, and then get triangle MPN.
Okay,
But you
I get what you're saying. Okay, easier thing to do, which is gonna make more sense for everyone else, is to take 12 NP and put it over top of BA, which is 18. 12 over 18,
Oh.
which reduces to what?
Ooh, 4, 6.
And keep going.
Oh,
2, 3.
2/3. So close.
Okay, now we take
So,
MP, which is 18, right?
Mm-hmm.
And we put it over top of
27.
27. What's 18 over 27 reduced to?
2/3.
And then we take 26 and put it over top of 20, or over 39, and you get,
2/3.
do those all have the same proportions? Which is
So-
exactly what Liv said, because she said divide by 3, multiply by 2, which is 2/3.
Really?
Okay, so that's how you're gonna have to prove it. You're gonna have to prove it by showing me that their proportions are the same.
You want the thing?
Yeah, I wanna see
He
that.
likes big
All them
fun.
sixes.
Okay, here. How can I show that all 3 triangles are similar?
Wait, now you're gonna be nice because you're from.
Oh, shoot. Oh, wait, oh, that's hard to click, I think. Alright,
Okay, so,
Oh, okay.
Okay, what, Caleb?
alright, so C,
Uh-huh.
B, A, congruent to D, E, F, and.
How do you know that?
Because it shows it.
No, it doesn't.
Yes, it does. It says that angle's.
Olivia?
Can I walk up there?
Yep.
It's back to
Wait, can I see calculator? I need quick
It says
math.
that
Quick math,
angle's
quick
that
math.
angle's.
Yeah, but you have to have 2 angles.
Those are.
gotta show off for the.
Oh, I get it now. Okay, now I see.
Go for
It
it.
don't work.
See what you need.
It don't work. I was gonna do some math. When I
Oh, wait, you can work it out like
It's
that?
two.
So these two equals 76. 76 plus 104 equals 180 degrees.
Good answer.
So the, so if this is right, they're all similar because they all have the same angles. They might not have the same sides, but
But that's
we're not
fine
looking
because,
for congruency, we're looking for
Right.
similarity.
right,
So these all point out to 180 because this can only have 29 degrees, this can only have 47 degrees, and this can only have 104 degrees.
correct,
Dang.
She dropped the mic.
Alright, y'all.
correct,
This girl, cool.
good.
Turn it so she can see the thing.
This girl is smart. She just did some crazy math. Let me show y'all what she just.
Okay,
It's hard.
She changed it, y'all. Alright, we'll get back to it some other time.
so then you have the application, process of this, okay? So surveyors use this a lot when they are doing surveying for, building buildings, how high they want them to go, what they want them to look like, all that fun stuff. Okay, so here you have a girl that's 5 foot tall. She's standing 8 feet away from this person surveying or whatever, taking a picture. Who cares? Okay,
Is that a woman?
the person is 300 feet from the building. I want to know how tall the building is.
What?
This a depth perception.
Yes.
Depth,
I've done this
depth
perception.
perception.
How can I set up an equation to figure this out? What do you know about triangles if they're similar? They have the same
Serious.
Angles.
angles and they're, what else is the same?
The side length?
No?
Oh, no. Come on, Dan.
Starts with a T,
Proportions.
the proportion
That's
of
what
the
I'm
thing.
trying to say.
So what do you think you have to set up to solve
A
this?
proportion.
A proportion, yes, pretty.
An
Right
equation that has a.
I remember doing
Brady.
it in math class.
Brady got something right.
Olivia wants to come up again.
What time
Oh.
But
is it?
I
No, we're
Coming up?
not third.
don't have to.
What time
No, I
is
should
it?
go now.
Okay.
The people want this.
I wanna watch.
I wanna watch.
Because I don't know what's doing right.
Alright. Here
Okay,
she
tell me
comes.
what you wanna do.
The bills are.
Alright, this is Olivia Reese, y'all. Watch this quick maths. We
David.
can't see it right now. She's
David.
writing something nice.
Okay, so she says 5/8, because that's the small triangle, equals x over 300. Correct. And then you can cross multiply, so you get 8x, or yeah, 1500. 1500 equals 8x, right?
Oh, I can't see
I
anything.
know, it's hard. You gotta get used to it. What's 1500 divided by 8, people?
1500 divided by
Quick
eight.
math number.
Quick math, use a calculator, 187.5.
Yes.
So 187.5 feet.
Dang, you could know.
Beautiful.
That's what it's
Okay, so that is your answer. It's 187.5 feet tall. No, not the hypotenuse, the height.
Oh, wait, what?
The
You're
height.
finding the height.
Oh,
Wait, is it?
I can just erase that.
Brady, you got 6 things right.
Dang.
See?
I'm killing it this year.
We'll delete that post-it note.
That's good.
That was your third quickest one during this
Oh,
talk.
nice.
What?
You
Okay.
have to note on how many things he just right.
So, you have to set proportions when they're similar, and then you can solve for a missing side length or height or whatever that you need, or the distance of something. Okey dokey. Okay,
Artichoke.
that is what your homework is over. It's on the board.
Pick up the phone.
289, 1 through 7, all. 9 through 33, odd.